Alright, in this video we're going to talk about dilations about a specific point. Now this is going to be one of the most difficult concepts that we cover in all of geometry, but really walk me through this, or walk through this with me. So here we have this point A. It says we want to dilate the triangle below, so this triangle here, BCD, by a scale factor of 3, with point A being the center of dilation. Okay, to start this problem off, let's go ahead and start labeling some things. Let's say, you know what, we know that A is going to be this point here at 3, 2. I see that B is going to be here at 0, 3. I see that C is at 2, 1. And I see that D is over here at 1, 0. Okay, more or less what we're saying is we're going to take this shape right here and we are going to enlarge it. Now let me pause this and let's kind of clean this up just a little bit. Okay, so we're going to talk about dilations about a point. Now in that previous graph we were given that our scale factor is 3, our point of dilation A was 3, 2, and let's go ahead and look at one specific point. Let's go ahead and look at point B. And I see that point B was at 0, 3. Okay, well we actually have kind of a crazy formula for this. So here's going to be our formula. And you, at some point, will have to memorize this. Alright, so we have the formula here, which is H plus T parentheses, X minus H, close parentheses, comma, K plus T parentheses, Y minus K. Okay. Now this looks insane in the beginning, and the way that you're going to tackle this is by being very, very diligent in the things that you write out. So let's do some labeling here. Thing number 1, our scale factor is actually this letter T. So let me kind of label that right there. There's our scale factor, and there is our scale factor. Okay, and so we would say that T is equal to 3. Okay, what else do we know? Well, our point of dilation is always where we're going to get our H, K. That is really, really important. The point of dilation is always going to be our H, K. And whatever specific point we choose, that will be our X and our Y. So let's see, what would this thing look like if I fill it in from left to right? Well, I see that my H value from my point of dilation is 3, plus my T, my scale factor, is also 3 parentheses. Now here we're going to put in X. This is from our specific point, that's 0, minus H, which once again is this 3 from our point of dilation, comma, and now we're going to start talking about the Y values of all these things. So our K value, this is the Y value of the point of dilation, so that's going to be 2, plus our scale factor, which is still 3, parentheses, the Y value, remember the Y comes from the point that we chose, 3, minus, and once again K, which is the Y value of our point of dilation. Okay, now this is the setup. So if you get here, I feel confident in your mathematical solving abilities for you to be able to finish this out. However, getting to here was the difficult point. Okay. So I've rewritten this, now we have space to work down, and how would I tackle this if I were you? Well, I would always do this in parts. I would do the simplest parts first. Alright, so we have this big long mess, and I'll just write 3 plus 3 parentheses, comma, 2 plus 3 parentheses. And what am I going to do? Well guys, I'm always going to simplify what's inside the parentheses first. So 0 minus 3 is simply negative 3. 3 minus 2 is 1. Okay, now when I see two things side by side, I'm going to multiply. So I have 3 something, comma 2 something, and right here 3 times negative 3 is negative 9. 3 times 1 is positive 3. Okay, and now I can finish off my problem. 3 minus 9 is going to be negative 6, comma 2 plus 3 is 5. And here is our point b prime. So after dilating everything about that point A, here's my point b prime at -6, 5. Sorry guys, I'm having a hard time finding the pause button here. So pulling back up this original graph, let's go ahead and go to the point -6, 5. So I go to -6, and I go all the way up to 5, and I see this point, and this is my b prime. So notice a couple things here. From A to B, if we were to look at the slope, well, I guess going from left to right, you would go down 1 and to the right 3. To go from B prime to A, you would go down 3 and to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. Check it out, guys. You've actually gone triple the distance in each one of these components. Also notice that if I draw a line from A to B prime, that it will be a straight line through all 3 points. So this is something kind of interesting. When you're dilating something by the scale factor, you're also multiplying the slope by that same scale factor. And so your points should always lie on a straight line. Okay, let's go ahead and we're going to do point D together. Okay, so once again, when tackling these problems, you want to really clearly and concisely label things. And by the way, if you think this is a lot, I promise you this. After you do this a couple times, it actually gets pretty easy. So let's go ahead and label our points, or label our points of interest. We know that 3 is this value t for our scale factor. We know that for our point of dilation, that will always be h, k. And for any given point that we choose, it will be x, y. Now what's the formula? Well, the formula is h plus t, parentheses, x minus h, close parentheses, comma, k plus t, parentheses, y minus k. And guys, I just did that from memory. You can kind of tell I was a little hesitant there in some parts, but when you do this enough, it actually becomes pretty simple. Okay, so let's plug in all the things we know. We know that our h value is from our point of dilation, that's 3, plus our t value, our scale factor, is still 3 parentheses, but here's where it changes. Our x value is 1, minus, of course, our h value. And notice, guys, there's an h at the beginning and the end, so it's kind of easy. Once you get that, you can kind of copy it down. And here our k value is kind of the same thing. It's a 2, and notice that k repeats itself, so you know at the very end of this we'll have another 2. Our t value, our scale factor, is still that plus 3. And what's our y value of this point? Well, it's going to be 0. 0 minus 2. Okay, now from here, remember, I always want you guys to start by simplifying what's inside the parentheses first. So, what would that look like? 3 plus 3 times something, comma, 2 plus 3 times something. And here, well, we have 1 minus 3, which is negative 2. We have 0 minus 2, which is still negative 2. Hey, that's kind of easy. Now from here, we'll always do our multiplication next. So, we'll do parentheses 3, and let's see. Oh, 3 something. Notice I'm kind of leaving myself some space here. And we see that 3 times negative 2 is negative 6. 3 times negative 2 is still negative 6. And lastly, we can finish this problem out. 3 minus 6 is negative 3, comma, 2 minus 6 is negative 4. And here is our point for C prime. Now let's see what that looks like on the graph. Oh, I'm sorry, not C, but D prime. Okay, here we are back on our graph, and we just found that D was at negative 3, comma, negative 4. So I come on down here and say, okay, well, there's my D prime. And notice that I can draw a line from A to D prime, and it will be a straight line. Also notice for my slope, if I go down 1, 2, and to the left 1, 2, okay, or more accurately, you know, we would go here to the right 2 and up 2. Well, if you multiply that by 3, we're saying, hey, from D prime, we should go up 6. 1, 2, 3, 4, 5, 6. And to the right 6 again, 1, 2, 3, 4, 5, 6. Yeah, because if it was originally up 2 and to the right 2, well, you multiply both of those by 3, you'll go up 6 and to the right 6. And yeah, it's kind of multiple ways that I'm expressing to y'all what it means to dilate a point. Now, here's the last thing. I'm going to go ahead and give y'all C, because these are all worked out the exact same way. So here, your point C would actually be over here at 0, -1, which is right here. Here's what C prime would look like. And notice that if I complete this triangle here, it's literally this same triangle, except for it is 3 times larger than the original triangle, and is 3 times further away from point A than our original triangle. And here's one final thing that I want to show y'all. If you were, in fact, to connect these lines, this dilation, what you would notice is that you've actually created a 3-dimensional figure. You've actually completed a, what would this be? A triangular pyramid. You've created a triangular pyramid. Alright guys, let's go ahead and move on to our next lesson.